Well, the scientific world is all a Twitter tonight with word of discovery of a new solar system with Earth-like planets. That means they're about the size of Earth, and they're orbiting suns in what are called habitable zones, close enough to the sun to support liquid water, but not too hot to support life, kind of like this planet. This discovery comes from NASA's orbiting Kepler Telescope, which has so far identified about 1,200 planets outside our own solar system. Joining us tonight to talk about the discovery is Dr. Rob Thacker, professor in the Department of Astronomy and Physics at St. Mary's University. Are you all at Twitter about this? Is this exciting for you?
Absolutely. It's not very often that discoveries come along that set the professional community chattering amongst themselves, but I have to say this is one of those.
Why is this such a big deal?
Because in one fell swoop, we've trebled the number of planets around other stars that we know about. And for just to have a game breaker like that in just like one release of data is just unprecedented.
I want to talk to you about what we know or what we think we know about these planets. What's the thinking about them now?
Well, I have to say that the things that we'd like to know about them, like do they have life on them and things like that, at the moment that's just out of reach. So what we really know about these planets now is just how far are they from their stars and basically how big are they.
And how big are they?
Well, we see a huge range, like we see from the smallest little things about the size of the Earth up to really super Jupiters, much more massive than Jupiter in our own solar system.
And these are our neighbors, and they are close in sort of, galactic
relatively
terms. But
speaking,
how far away are they, Rob?
Well, they're still, in some cases, hundreds of light years away. So if you wanted to get there, it would take you a heck of a long time.
Let's talk a little bit about the so-called habitable zone, or the Goldilocks zone, which you in astronomy and physics talk about. What is it?
Well, you basically hit the nail on your head earlier when you discussed it briefly by saying it's a region around a star where liquid water can exist.
Right.
And the reason for this is we think liquid water is extremely important in the creation of life. So we basically look for a region around the star where this can actually happen. Now, calculating that is a little bit tricky, but by and large, if you know how bright a star is, you know how hot the surface of the planet is at a given distance, and then you can work out, is it warm enough for liquid water?
So in our neighborhood, in our solar system, is the Earth it? Are we the only planet in the habitable zone?
So in our own solar system, Mars is kind of on the very outer limit of it, right? But basically, yeah, we're in definitely the best place.
Now, the Kepler is a telescope, but of course it doesn't actually see planets. I mean, it's not like in your backyard where you look through the spy hole and all of a sudden there you see the planets. So how do we know that these planets are actually there?
So it's a very ingenious method. So basically, if you were to imagine that I had a torch and I just run my hand in front of the torch, I block the light for a very short amount of time by doing that.
Okay.
Now, if you replace the torch with a star, and a planet goes in front of that star, then the amount of light goes down just a tiny bit. How tiny? It's a bit like trying to see a gnat going in front of a headlight 10 miles away.
I was going to say, it wouldn't be like a lunar eclipse or anything.
No, I mean, we don't call them eclipses because of that. We call them transits because the planet transits in front of the star. It's incredibly hard to see, and that's one of the reasons why we put the telescope above the atmosphere.
So are we sure? I mean, is this more than hypothetical, the existence of these planets?
So we actually do have images of planets around other stars. In fact, Canadians lead the world in this, I'm really proud to say. And that was just done about 2 years ago. So we have images of one particular planetary system, but the ones we're talking about today, then we're just really inferring that they're there.
How can we find out if, in fact, there is anything on these planets? Since we can't even see them, how are we ever going to fathom whether there might be life on them, which is, after all, the big elephant in the room here, isn't it?
That's the $64,000 question. So the best way to do that is to actually look at the atmosphere of the planet itself. We've actually already done this, right? As the planet goes in front of the star, it will absorb a little bit of the light coming from the star, and we can analyze the light and we can see this. So if you can test what the light coming from the planet itself is and how it processes the star's light, then you can infer what its atmosphere is made up of. Now, the key thing there is, why is that interesting? Because if there's life on the planet, then there's probably going to be ozone, oxygen, a bit of carbon dioxide in this atmosphere that we're going to be able to see and trace.
We, of course, as a species, have long wondered about the existence of life, any kind of life, elsewhere in the universe, let alone intelligent life. But as a scientist, do the facts as you know them today suggest that there is probably life somewhere else, or that there is probably not life somewhere else?
It's a tough question to answer. We can go through the steps that we need step by step, but I'm still going to say I'm speculating by saying this.
All right.
I subscribe to something called the rare earth hypothesis. And basically the idea is that if you put all of the ingredients you need for life, you need certain elements, you need water and so on, then basic life like bacteria forms fairly readily. On the other hand, more complex life like you and I seems to be a much harder process to get going. So I think there's definitely simple life out there in our galaxy. As for analogues of you and I, well, I would hope for maybe half a dozen, but I'm completely speculating.
But again, even if we are rare in a universe with potentially millions and tens upon millions of planets,
Yep.
there's probably a chance.
Once we go beyond our own galaxy and start considering the billions and billions of other galaxies in our universe, then definitely.
Are we ever going to get to meet any of this life, or at least look at some of this life, or get to another planet where there is some life?
Well, that's a really fun question. It's probably more likely if they're advanced, they'll get to us first.
They must be more intelligent than we are.
One would think so. They could have arose billions of years ago, so
Yeah.
who knows what technologies they'd have.
They might be already gone.
Yeah.
Of course,
But
by the time we see the light from these twinkling stars, it's already millions and millions of years old.
Well, so the ones that we're looking at the moment with Kepler, then it's hundreds, at most thousands of years. So it's not that long ago.
Okay.
Right, but once we go outside our galaxy, then yes, you're talking millions, in some cases billions of
What are
years.
the chances we're going to hear about life somewhere else in our lifetime?
I'm quietly optimistic that within my lifetime, and perhaps yours as well, Steve,
Yep.
then we'll know the answer to this as well. And there are telescopes on the drawing board right now that should be able to get us answers to those questions.
Well, I'll hope for you, if not for me. I appreciate your time, Dr. Rob Thacker. Thanks for coming.
Thanks very
Fascinating
much.
discovery. Dr. Thacker teaches in the Department of Astronomy and Physics at St. Mary's University. Back in just a moment.